Welcome to a video in which we will look at some specific attributes of members or nodes in a network. We'll look at degree, we'll look at betweenness, and we will look at closeness. And we'll see where those values come from and how to calculate them based on this tiny hypothetical network that you'll see here. So first, I'm just going to bring in the igraph package. We have the network right here. Now, if you are a fan of the TV show The Wire, some of those names may look familiar to you. And if you're a big fan, you'll probably criticize the missing connections here between some of the members of the network. But please just bear with me. It is here for mostly hypothetical purposes. So if you're wondering why two characters aren't connected, there's no good reason. So mea culpa there in advance. All right, so what we're going to do here is we're going to run these next two to set up the conditions for graphing this. So this is going to be an undirected network, and that is meaning that the connections are simply connections. We don't have a situation where one person is following another, or there's some kind of asymmetry between them. This is just undirected, and everybody who's connected is just mutually connected. So there is that line, and then we plot this there. And there's a couple specifics. I set the vertex label distance just to help a little bit with readability of some of the names. But those are settings that you can play with in terms of how the graph is going to look. But what really counts right now is we've got the graph there on the right, and we'll start with degree. And degree is pretty straightforward. I'll run that right here, and there it is. So what we can see, let's take a look at a couple, even though I said, well, it's so straightforward, but well, what is it? So let's see who stands out. Well, McNulty stands out, and McNulty, we're just literally counting. So we're counting McNulty's direct connections, and his direct connections are to Carver, to Bunk, to Stringer, and to Lester in a counterclockwise direction, starting with Carver, and that's why that's 4. And someone like let's just say Avon is directly connected to Weebay, D'Angelo, and Stringer, so those are the 3. And the other ones you see are 1 for the same reason. And with Stringer, you can see why that's 3 as well. So I won't say anything more about degree here, but I'll move on to betweenness. Betweenness is an interesting metric, and someone in a network could have a very, very high betweenness score when that person is a connector between different parts of the network. So it could be someone who is like a courier or a messenger if it's a network that's spread out across different areas. It could also be, if we're looking at things like routers and we're looking at internet infrastructure, something that is like a central hub in a network where a lot of traffic flows in and out from other smaller networks, that would have a high betweenness value. So let me run it, and we'll take a look at some of the betweenness values here. And what you'll notice right off the bat is most nodes have 0. And that's because, if you're wondering, well, why are those 0? Well, they don't sit on the shortest path between other people, other nodes on the network. And so anyone who's peripheral is going to have a 0 there. But let's look at some of the people who aren't peripheral and kind of see what's going on. So I'll just pick Avon here with 13, and I want to kind of just dig into that and see why. Where Avon sits, if we take D'Angelo and we try to connect D'Angelo to anyone else in the network, what we find is that those paths run through Avon. So, for instance, if we want to take D'Angelo and connect him to Weebay, we're going to go through Avon. If we want to go get D'Angelo to Stringer, it has to go through Avon. We want him to get him to Bodie, well, it actually has to go through Avon and Stringer. So for the relationship between anyone else and D'Angelo, for all of those, Avon sits on that path. So 1, 2, 3, 4, 5, 6, 7. So those are 7 such relationships. And what you might see here already is, well, what about the other 6? Well, those are for Weebay. So for Weebay, what we know is that Weebay is gonna have to, anyone who Weebay goes through is gonna have to flow through Avon. And you might be thinking, well, wait a minute, why is it 13? Why isn't it 14? Well, we don't double count the relationship between D'Angelo and Weebay. Remember, it's an undirected network, not a directed network, so we can't double count any relationship. So if I say for D'Angelo there's 7, well, for Weebay, you could say, well, there's also 7, yeah, but one of them was already spoken for when we counted D'Angelo's connections. So that is why that number is 13. It would be a little more complicated for somebody. Let's pick somebody else, though. Let's look at Stringer here. So Stringer has the highest betweenness value, which is interesting, right? Because that means that there's something essential about Stringer in the way that he connects these different groups. And so we see Stringer there with 19. And the process we'll use, it's a similar kind of idea. And the way you might see here, like how Stringer connects people, and we could actually calculate it from either side of the graph. But what we'll do is we'll start with Avon. So for Avon to go to 1, 2, 3, 4, 5 other members of the network, that is going to have to go through Stringer. And for Weebay to go to 1, 2, 3, well, excuse me, 1, 2, 3, 4, 5 other members of the network, that is also going to have to go through Stringer. And then if we look at D'Angelo, we're going to find that for D'Angelo to get to any of those same 5, for D'Angelo to go 1, 2, 3, 4, 5, those also go through Stringer. So that puts us up to 15. And then for the other 4, we have the connections between Bodie and Bunk, Carver, Lester, and McNulty. So those other 4 take us to 19, and that is why Stringer has a betweenness value of 19, because of the unique connections that go through Stringer, that for which Stringer sits on the shortest path. So I know there's one that I didn't break down there, McNulty, but see if you can figure that out. Why is McNulty 18? Using the same process, same kind of methodology. The last one we'll look at for this video is going to be closeness. So let's take a look at that. Okay, closeness, it looks like what the heck is going on here? And reading the definition of the way we calculate this, it sort of might just sound like a lot more jargon. But for what it's worth, the closeness is the reciprocal of the sum of the path lengths to all other nodes. So, okay, I feel like we just have to see this. And what you'll see when we do it, you'll see that for members of the network that have a higher sum of path lengths, it means that they're on average further away from other people in the network. They are going to have lower values for closeness because we sum those, and when we take the reciprocal, high values are going to become smaller values and lower values are going to become higher ones. It won't always be the case that members of the network with the highest betweenness scores have the highest closeness scores. In this particular network, they do seem to be pretty well correlated, but that is not a guarantee. It could be just all has to do with how the network forms and the specific characteristics of what someone with a high betweenness score is what is their position and role in the network. So I can come back to that in another video, but what I'm going to do right now is just pick a couple characters. I won't do them all, but we'll break down a couple of them. So let's take a look at Avon. And so as we go, so we see Avon's closeness score right here as 0.0625. And what we want to do is we want to look at the distance between him and other people in the network. So what we're going to do is we'll say Avon to D'Angelo is 1. Okay, so that's 1. We'll say Avon to Weebay is 1. Avon to Stringer is 1. And we have to do this. We have to go through all the network, which is why it's kind of good. This isn't a very huge network. But Avon to Bodie, that is 2. I almost wrote 1, but that's 2. Avon to McNulty, that is 2. And Avon to Bunk, and that is going to be 3. Avon to Lester is 1, 2, 3. And then Avon to Carver is going to be 1, 2, 3. Okay, so we have all those values there. The next thing we need to do is just sum them. So we've got 3 plus 2, so that's 5, and then 7, and then 10, 13, and 16. So the sum of those values is 16, and then we just say this. We just take the reciprocal of that value, and we say that is going to be Avon's closeness. And sure enough, that's what you see there. And what I'll do, I'll just pick 2 others, and then I'll leave the rest to you if you want to go through these and kind of just work your way through just to see it a little bit more. We'll take someone with a relatively low score. So I'm going to pick Weebay for this. And with Weebay, what we find is, and what I'll do, rather than write it all out up here, I'll just go through and keep track of it as I go. So Weebay's closeness, so we sum those path lengths. We'll start with Avon, we'll say that's 1. We'll go to D'Angelo, and that is 2. Weebay to Stringer is 2 more. Weebay to Bodie is 3. Weebay to McNulty is 3. Weebay to Bunk is 1, 2, 3, 4. And Weebay to Lester is 1, 2, 3, 4. And then finally, Weebay to Carver is 1, 2, 3, 4. So when we sum those up, we have, let's see, 18 plus 4, that's 22 plus 1. So 23 is the sum of the path lengths from Weebay to all other members of this connected network. And that is what we see there. And then finally, what we'll do, we'll pick, we'll pick the person with the highest closeness value, which is Stringer. So let's bang that one out, and then I'll wrap up after that. So we've got, for Stringer, I'll work the left side first. We've got 1 to Avon. We've got 2 to Weebay, 2 to D'Angelo. We've got 1 to Bodie, 1 to McNulty, 2 to Bunk, 2 to Lester, and 2 to Carver. So with Stringer, once we sum those up, we get 13. So what we can do right here is take a look and see that is Stringer's closeness. So you can follow the same path, the same methodology. What we looked at here was degree, which we simply count direct connections. Betweenness, which is a little trickier. We have to be careful not to double count here in this undirected network, but it's the number of relationships for which you're sitting on that shortest path. Each one of those contributes to your betweenness. And your closeness is, as listed right here, reciprocal of the sum of path lengths to all other nodes. So someone who's has shorter number of path lengths to get all around the network is going to have a higher value for closeness. And I'll just mention, I know I said earlier that betweenness and closeness aren't necessarily going to be so directly related. An example there is, suppose I said earlier that someone who's like a messenger or a courier could have a high betweenness value, and it's possible that that member of the network is connecting 2 disparate parts of the network and isn't actually very closely connected to anyone in either of those 2 different parts. That person could have a very high betweenness score without having a very high closeness score. And as I said, I can cover that in a separate video, but that is the basic breakdown of these metrics for this network, and I hope you enjoyed it. Thank you for watching.